Okay, for this video, we're going to talk about atomic orbitals and what an atomic orbital is. Okay, so far we have developed what scientists think the atom looks like, okay? And the last main one that you talked about was Niels Bohr, right? And Niels Bohr said that there was a center core, and then the electrons are orbiting the core, which was the nucleus, like planets orbit the sun. Okay, so he's right to say that each orbital will be a different energy level. His understanding on where the electrons are located, however, is not entirely right. We're going to deal with this thing called atomic orbitals, okay? Now, orbitals, you're still thinking of electrons orbiting the center of the nucleus. However, electrons are way too small and move way too quickly for us to be able to talk about where the electron is at any given time, okay? So, instead of talking about the electrons taking a path around the nucleus, we're going to talk about regions and where the electrons could possibly be, okay? We can say with high probability that these electrons will be located in these sort of atomic orbital type things. Okay, so let's talk about atomic orbitals and what it means for something to be an atomic orbital. If you look in your notes, it says it gives you an atomic orbital is talking about a region in space in which there's a high probability of finding an electron. Okay, so we're no longer talking about this electron possibly being on a nice little orbital path. Now we're talking about the electron could be anywhere within that orbital path. Okay. Each energy sublevel is going to correspond to an orbital of a different shape to describe where those electrons are located, okay? Now we're going to talk about shapes because we're going to give these electrons a lot of space to possibly be, okay? And then the orientation of the shape is going to be what it looks like around the nucleus, okay? We're going to talk about 3 different orbitals, all right? And so what I want you to do is grab 3 different colors, okay? The first one I'm going to talk about is the s orbital, okay? The s orbital. When I'm talking about an orbital, excuse me, I'm talking about the fact that one orbital can hold maximum 2 electrons, okay? So the s orbital, considering it can hold 2 electrons, means that anywhere within an s orbital, there could be 2 electrons somewhere in that region, okay? And you'll notice that the s orbital kind of looks like a sphere, okay? So there's only one orientation, only one orbital that can hold 2 electrons, okay? So, and we're going to call these first 2 rows here, so this is on the next page of your notes, these first 2 rows here, the s block. Okay, so all of these atoms within this s block, and we're going to say including helium, these are where the 2 or the s electrons or the s orbitals is going to be looked. So this is the s block. Okay, and it's called the s block because if s can only hold 2 electrons, that means that each one of these atoms, right, if I move from left to right, I'm going to be moving from 1 electron or 1 valence electron, outermost shell electron, to 2 electrons. 1 electron to 2 electrons. 1 electron to 2 electrons. So I'm not moving up electrons. Okay? So that's the s block. The second orbital that we can have is called a p orbital. Okay? Now you'll notice that I have a px orbital, a py orbital, and a pz orbital. Okay? So all of these orbitals could be a high probability of where the electrons could be in a p. Okay? Now you'll notice the orientation of each p orbital. I have one on the x-axis, one on the y-axis, and one on the z-axis. The z-axis is the 3-dimensional aspect of the atom. Okay? And they kind of look like dumbbells, right? Like you work out like a dumbbell. Where can I find, so now if I have 3 different orbitals now in a p orbital, how many electrons do you think can go inside of the p orbital? So here's one orbital, here's a second orbital, here's a third orbital. If each can hold 2 electrons, how many electrons total can the p orbital hold? I hope you said 6, right? Because 2 plus 2 plus 2 is 6. And would you look at this, the way that our periodic table is set up? I lost my screen. The way that the periodic table is set up is if I look over here to this block, I'm going to have 1, 2, 3, 4, 5, 6 possible places where those electrons could be located. So we're going to call this guy the p block. Okay. And then our last possible orientation that we're going to talk about, or possible orbital that we're going to talk about, is the d orbital. Okay. Now you'll notice, how many d shapes do I have? Well, if I was to count these, I would have 1, 2, 3, 4, 5. I'm not so interested in that you can tell me the shapes of the d orbitals. I'm more interested in you being able to tell me how many electrons can I hold total in the d orbital. If this orbital can hold 2, and this orbital can hold 2, excuse me, this orbital can hold 2, this orbital can hold 2, and this orbital can hold 2. The d orbitals can hold a total of 10 electrons. And if you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be our d block, or where all the d electrons will be located. Okay, so that's it for orbitals. We'll talk a little bit more about the orbitals when we start doing electron configuration and orbital notation, which takes Niels Bohr's Bohr models one step further. Okay, thanks for watching.